Hello everyone. In this video, we will learn about the object-oriented principles. The first question that should come into your mind is why we are learning these principles. So, in a domain of software engineering, before making any program, we should have the benchmark. We should have the foundation on which the particular program will be built on, right? So, the foundations or the pillars consist of these four principles that are encapsulation, inheritance, polymorphism, and abstractions. Without these principles, we can't make the code better. Or you can say that these principles are responsible for enhancing the code, enhancing the readability, and it makes the code user friendly. The user understand the code very well. If we are making anything without any foundation, we will not have the solid, you can say, the concrete results, right? So that's why these particular principles are very important before building any program or algorithm. So let's get started. So what I have done is I have chosen the domain of machine learning. So using these machine learning algorithms, I will explain you these principles, right? So let's get started. So this is the UML diagram of how I created these algorithm. We will learn this later. The first principle is encapsulation. So uh, if you're writing any code, right, it should be in particular order. The code should be representable to the user. So encapsulation is all about bundling up the data or attributes and method that operate on the data into a single unit or class. So it's basically we are segregating the attributes and methods or the qualities of the program into a particular class. It's like an umbrella, right? The person is under the umbrella and the umbrella is protecting the person, right? So basically encapsulation is basically integrating the code. It's basically combining all the features of a code into a single area. That area is called the class. So encapsulation is all about ensuring that any modification to the learning parameters are done through methods and maintaining the integrity of the model. The word integrity here means that we don't have any hodgepodge, or you can say the code is less, you can say, readable, right? The code is very much neat and clean. It's under particular order. So encapsulation helps us to do that. So let's take an example. So in this particular code of decision tree, so I have created a decision tree from scratch. Here we can see that all the fit method, build tree method, right, split is under the same class called decision tree classifier. So this is what encapsulation help us to do. It's integrate the code, right? So let's come to the next principle, which is inheritance. So as the word inheritance states that it is basically inheriting the quality from your parent, right? The son or the child inherit the quality from their parents. Similarly, in the code, when we are writing any program or algorithms, the code also inheritance qualities and attributes from the parent class. For example, here we can see that the base model, right? So the base model has some function, right? The learning rate, maximum iteration, random state, regularization, class weights, and again the fit and predict functions, right? If we see any algorithm, let's say k-nearest neighbor, right, we will see that it is inheriting these you can say particular functions from the parent class, which is the base model. Similarly, light gbm, let's it's an light gbm, it's the another machine learning classification algorithm. Again, we can see that it is inheriting from the base gradient boosting, right? If we see this particular algorithm, so light gbm is inheriting from this particular class, right? And this particular class is inheriting the attributes from the base tree. So base tree is this particular class, right? So we can see that inheritance enables us to inherit the qualities and attributes from the parent class. It ensures that we are not writing the code many times. It reduces the repetition of the code. If we are inheriting something from the parent class, we will write the code, we will not repeat the code, right? So the benefit of inheritance is the space optimization. We are reducing the space. So again, we are done with the second principle, which is inheritance. It allows k nearest neighbor to utilize the fit and evaluate method from the base model. We have seen that in a code, right? So inheritance is again the very very important principle when we are developing any software. The third principle is polymorphism. It allows method to be defined in the base class and overridden in the derived class. So it's very confusing, right? So what's happening is, suppose, let's take an example. Let's say base model, right? So we can see that we have two functions, right? Predict. We Be careful, guys. I have defined predict and fit function in the base model, right? This particular method or this particular functions, let's say cat boost, right? So this particular predict method is also inherited in the cat boost, but here the implementation of the predict function is different from the base model. Here we can see that we are raising an error here, right? We are raising an error here. But in the cat boost, we are redefining the predict function and we are predicting the results here. So that's what polymorphism is. Polymorphism is basically, poly means multiple, right? So it is basically allowing the multiple functionality to the class. Here, we are also raising the error as well as we are also predicting the results. So we have two functionality in a single function, right? So that what polymorphism is all about. This feature enhances the flexibility of the code. We are making the code more flexible and dynamic. Now our code can do two things. The first is it is predicting, right? We have defined the predict function in the cat boost. But again, in the base model, right, we are raising an error. The subclass should implement this method. The subclass is in the cat boost. So again, we are raising the error as well as we are predicting the results. So these two things are being used in this particular class. So polymorphism allows us to do that. It makes the algorithm or program more flexible, right? The method of overriding. So again, we have particular rules, right? So we can see that each class can implement its own version of methods like fit, predict, and evaluate while adhering to the same method signature defined in the base class, right? So suppose first it will implement the result of the child class. If the child class has empty, which means that if the predict function is empty here, right, then we will have the results from the base or parent class. So that what polymorphism is all about. Both classes implement their version of evaluate, demonstrating polymorphism while maintaining the same interface. So polymorphism enhances the flexibility and dynamic. It makes the code very dynamic. And the last principle is abstraction. Abstraction involves hiding the complex implementation detail of the system, right? What do you mean by the hiding the complex implementation? See, when you are making any program or software, you will the client or the customer is not considerate about the implementation of the code. He just care about the product, right? So he don't want to see the code. He want to see the product. So abstraction is all about hiding the complex implementation of the code. For example, if you're using any banking system, are you interested about the code? No, you just wanted that those function the product should have deposit withdraw functionality, right? You are not considerate about the code at the back end. So abstraction allows us to do that. This particular method, which we have used in the static method is all about hiding the complex details of the code. So this particular principle is all about hiding the complex and hard implementation of the code so that it is more representable. The code is more representable to the customer. So this forces derived classes to implement these methods, thus maintaining a clear contrast from model behavior. So it is basically hiding the complex detail that says so that the code is more readable and understandable to the user. So in conclusion, the design of classification of machine learning algorithm effectively employs or implement these object-oriented principles, right? So I have created a little demo like how I have created these particular algorithms from scratch, and we will also compare the results of these algorithms from the sklearn library. So the sklearn library is again built built on using these four principles only, right? Every program uses these four principles. It's not complex. It's just at the back end we should be very careful while implementing the code. So suppose like I have implemented the logistic regression from scratch. This logistic regression is inheriting the qualities from the base model. We can see that here. And again, we are defining some functions and attributes in the logistic regression class. And we are also defining the evaluate function, which is just the performance metric for the logistic regression. This is inheriting from the metric class. The metric class is being defined here. So all the qualities are being inherited in the logistic regression. So what I have done is I have created a Jupyter notebook. I will just import this algorithm. So here we can see that we are importing the logistic regression which we have created. So this is the logistic regression model, right? See, we have defined here. So we have just imported it. So again, so we have created. So again, we are also importing the logistic regression from the sklearn library. So sklearn is just the repository of the algorithms. We are importing the logistic regression from there. So again, we can see that in order to print the accurate, so we have created the dummy data. Wait, I'll show you the dummy data. Okay, so let's say X, right? Okay, wait a sec. Okay, so it is feature one. Yep. So we have created the dummy data here, right? Again, the feature two also. So in the feature one and feature two, or dummy data is there with some labels and features. We have feature one, feature two, and labels. So we will predict the output using the logistic regression. So again, we can see that the accuracy is 90%, the precision is 84, the recall and F1. Again, we have defined this function. This is a custom logistic regression we have built. So using the OOPS principles, we have built this particular algorithm, right? And using the sklearn, we are importing the particular function and we can see the accuracy and results. And let's plot this, right? So we can see that our function has drawn the decision boundary, but again, like we haven't implemented any complex implementation of logistic regression against the bias. Haven't done the regularization, or we haven't done the hyperparameter tuning. But again, like we can see that using these four principles, yes, we can implement the logistic regression from scratch. We have just used abstraction, encapsulation, inheritance, and polymorphism concept to just, and we have created this simple logistic regression model. And again, like it is working very good. So yes, like using these concepts are very, very important while designing any algorithm or program, right? We have taken the example of machine learning, right? But like this particular principle is versatile. It is implemented in all other domains also. If you're designing any software, whether it is banking system, if it's food delivery system, online e-commerce, movies, recommendation systems, everywhere these four principles are being used, right? So again, like using these four principles, draw we can make any program, right? So thanks for watching. I hope